For a one sample t-test, it's a test that runs one variable against a test value. Okay? What is a test value? It's a number the researcher chooses as basically just like a mean, what they believe the number should be for whatever it is. Let's say it's exam scores. I say everybody should score an 80. Okay? When I run the test, it's going to run at 80, and it's going to tell me if the group is below 80 or above 80. Okay. Again, I've talked about this a lot, always about Starbucks and that screen up there that runs the time for the thing. Just like if you've been to any fast food place and they're running behind and they ask you to pull out front. Well, when you pull away from that box that your car is sitting on, the timer stops. So they can shorten the time, and it gives the impression that they're getting food out fast, but they're really not. Okay, so if you think of it this way, you run something, throwing a pitching velocity, test scores, sprints, like we're going to look at the one we're going to look at today. Anything you can time, anything that's just a general number. This is the most basic of all inferential statistics. We're looking at the mean. Is your mean, your final mean, above or below the actual test value that you put in? So this is the first box you're going to see, and that this test is run on a 35-meter sprint. Okay, you don't know male or female because that's not what we're running here. We're looking at the group of 374 people running a 35-meter sprint. Okay, it's a one sample t-test, so we're running a one sample, okay, against a test value to see if it is that mean that is being reported is above or below the test value that the researcher has chosen. In this case, myself as a researcher, I chose 6.50. I made a guess and I left it at that. So let's look at the important factors. First off, what is the variable? It is sprint. And you'll see it right there in the box in gray. Next is, what are the number of participants? And you'll see the red line goes from 374 to 374, so the participants are 374. Next is, what is the mean? And that is, you can see the mean in above the box, and it's 6.58, and you'll see the arrow pointing right to where it is. And if you notice, everything is right in front of you. You can see right next to that number 6.58, it says written in parentheses, capital M, italics, space, equals, space, 6.58. Close the parentheses. And the last for this box is, what is the standard deviation? Well, you'll see STD period deviation, means standard deviation, is 1.23. And as you can see in the box, is written as SD in italics inside the parentheses, SD italics space equals space 1.23. The M and the SD are in italics. So to sum up the first part of this box, the important numbers for the 35-meter dash are the N, the number of participants, 374. The mean with a capital M italics in italics is 6.58, and the standard deviation, which is capital SD in italics, is 1.23. So this is the second box for the one sample t-test, and as you can see, the test value is 0.650. The variable again is sprint. You'll see it in the gray box. Next is the t-value, and that t-value is 1.29. The next is the df, which is 373. Next is the p-value, which is 0.20. You can see it in the box right above the 0.20, where you'll see where it says significance, or it could say sig, S-I-G, and it says two-sided p, which makes it the p-value. Now to analyze the p-value. Is the p-value above or below 0.05? In this case, it's 0.20. Would be above 0.20. With a p-value of 0.20, it is above 0.05. Therefore, the p-value is non-significant because it's above 0.05. Next is understanding the mean. You saw in the boxes that it gave you a mean value, but we're running that mean value against the test value. Is the mean above or below the test value? Period. So if we go back to what we learned earlier, and we said the test value was 6.50, and the mean is 6.58, the mean is above the test value. Again, when we draw the conclusion, we are looking the mean value versus the test value. Test value being 6.50 and the mean of 6.58. So the actual conclusion is, with a test value of 6.50 and a mean of 6.58, the participants ran slightly slower. Now, we've talked about the hypotheses before, but now let's put it into action. Remember, the HO is the null. There is no difference in the 35-meter dash. H1, there is a difference in the 35-meter dash. What do we need to choose, the null or the alternative? Well, the p-value is 0.20, which makes it non-significant. We can also see visually that 6.50 is not the same as 6.58. So there was a difference of mean to the test value of to the test value of 6.58. We take the H1. This is when we use the words, we reject the null and accept the alternative, meaning that there was a difference. Let's talk about the info for the write-up. First, we need our topic, 35-meter dash. Next is what test are we running? The one samples t-test, okay? And you see how it's written here, capital O, capital S, and the T is in italics. And the test is lowercase. I don't know why. Was it significant or non? And then you need to understand the t-value statement. The t-value statement is T, in parentheses, the DF, equals the t-value, comma, P, and equals the significance value. Okay? Or the p-value. Okay, so then you see how it's written for this one is T, no space, open parentheses, 373 was a DF, equals 129, comma, P is in italics, little p is in italics, space, equals space, 0.20. The T and the P are in italics, and all the numbers are rounded to the hundredths place, point blank blank. This is the entire write-up. Doesn't matter what the data is or how the data is put together, but you also need to look and see all the little letters such as the T, the P, the M, and the SD, how they're written and how they're set up. It's going to save you time and energy and a lot of editing if you just follow the directions as they're posted towards you. Let's examine the first line. To examine the participants' 35-meter dash times, a one sample t-test was performed. So, number one, the first part of the line stays the same. 35-meter dash is what you're testing. Okay? And then you have to tell them what your test you're running. So it's a one sample t-test was performed. Next, the results showed a non-significant difference. Now you look down at the next line and you see the p-value is 0.20, which means it's a non-significant difference. That's what should go there. In 35-meter dash times, whatever that variable is you're looking at. So the sentence reads, the results showed a non-significant difference in 35-meter dash times. And then you have the t-value statement. T, 373, which is a DF, you see the space equals space 1.29 comma P in italics space equals space 0.20 period. So the next sentence really pushes toward the mean and the standard deviation. So it's therefore there was a non-significant, again 0.20 makes it non-significant, difference in 35 meter dashes. You always got to keep reminding people what you're doing. And then you'll see the mean and the standard deviation is there, and the M and the SD are both capitalized and they are in italics. Now we're at like a concluding statement for the mean and the standard deviation, where it reads, due to the test value of 6.50 and a sample mean of 6.58. So now is where your critical thinking comes in, and you have to look at what that mean was compared to the test value, and you're going to draw a concluding statement that is extremely clear. You don't say that some are above and some are below. No. There is a direct statement that goes with each one, and you need to not add words to it. Don't fluff it up. Don't do anything. If it says whatever it says, you say it as quickly and easy, but you add words to it, and it changes the meaning. So that's the most important part. So this final sentence is the participants' 35 meter times were slightly slower than the test value. You're basically saying that they were slower. You could also say the participants' 35 mile times were slower than they were than expected. There's lots of ways you can say it, but it's very short, sweet, and to the point. But you have to analyze what you're actually looking at and draw the conclusion. In this case, above is slow, below 650 is faster.